Hey, so lesson 4, linear equalities in two variables. And this thing is sometimes you were like, wait a second, we've been working on systems of equations. And you're right, we have. So two equations, let's find where they're equal to each other. So this leads into 4.5, which we're going to see the systems, but instead of systems of equations, we're going to end up seeing systems of, well, there it is, inequalities. So today is just about working with inequalities, graphing them specifically. Whoa. All right, I'm back. Um, so graphing them specifically. So remember, let's take a little trip down memory lane. Oh, when we had less than symbols, greater than symbols, that's when we would use the open circle. And then we had the or equal to, the greater than or equal to, that we use the shaded in circle. So we're going to see some of those. Also remember that your solutions to your inequalities, there's lots of answers. All right, so like in the equality, like x is greater than 2, well, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget about the fractions and decimals that are there as well too. So there's lots and lots and lots of answers. And so that's why we graph it, is because it shows the visual representation of it. So here we go. The big thing here is a lot of kind of old people get it in slope-intercept form. Even though it's an inequality, you still treat it like it's an equal sign. All right. But the big thing here is it's a solid or it's a dashed line. Okay, well, how do I know? Well, it's the same thing as before. Solid means it's the or equal to's. All right, dashed is going to be your less thans and your greater thans. So just like we used open circle with those, here we used shaded in circle. So definite similarities. You're still going to graph like normal, but then we got to figure out which side to shade on. And that's the part where we'll end up picking a point that's not a line. And what we're going to do is what's referred to as a test. All right, enough talking. Let's get into it. So, hey, slope-intercept form, that first problem. So we're going to go right down to -1. All right, we're going to plot that point. We got a slope of 2, so it's rise 2, run 1, rise 2, run 1, rise 2, run 1. And so we're gonna get a few of them down there. Now, I'm not going to just go right away and be like, okay, draw my line, because remember, it's a less than symbol. It's a dotted line. All right, so you're going to get a dotted line going through there. And what that means, remember, is just like with the open circle, like if we want numbers x is greater than 2, well, 2 is not going to work because it's not greater than. So what that tells me is that if a solution falls on that dotted line, it's not one of our particular solutions. So, all right, graph, yes. And now we're ready to shape. Okay, so what we like to do is we like to test the ordered pair 0, 0. All right, and when you look at the ordered pair 0, 0, you can see that it is clearly above the line. Maybe you view it as to the left of the line, but it's definitely on one side of it, and that's what we always want. So what we're going to do is we're going to plug in that ordered pair, and we're going to see if we get a true or false statement. Hence why we say test it out. So if we're going to test out the ordered pair 0, 0, we're going to plug in the 0 for the y. All right, we're going to plug in the 0 for x, and we're going to see if we get a true statement or not. So let's see here. 2 times 0 is 0. 0 minus 1, that's a -1. Is 0 less than -1? No, it's not. So what that means is, no, that's not a solution. So we're going to go on the other side and shade. And what we're doing here is, I know it's not a really good job of shading, but we don't need a lot, that's theirs. What we're saying is any ordered pair you choose over there and you plug in, that's going to work. So if I grab like an ordered pair way up here, which is the ordered pair 9, 9. If I plug in a 9, all right, 2 times 9 is 18. 18 minus 1 is 17. Is 9 less than 17? It certainly is. No matter what ordered pair I choose, it's going to work. If I choose anyone that's on this other side that has 0, 0, it's going to end up failing. So again, all of those ordered pairs are solutions. Well, let's look at problem number 3. The main reason why I want to look at problem number 3 is because it's going to go through the origin. So, yeah, let's graph it. All right. So I've got my 0 that's there. All right, because that's where my y-intercept is at, and the slope of -3. So -3, 1. So down 3, 1, 2, 3 to the right 1, down 3 to the right 1. If I want to be fancy, remember negative 3 ones is the exact same as 3 over negative 1. So I could rise 3 and run 1 to the left. They're still all on it. I'm looking at my inequality symbol. So it is a dotted line. That's probably what you're going to end up kind of messing up the most, I should say, because you're automatically going to go to just simply drawing it because that's what you're used to doing. Okay, so the thing here is I can't test out 0, 0 because it's on it. So we just grab another point that's clearly not on it and is clearly to one side or the other. It doesn't matter. I'm going to stay with friendly numbers. So I'm going to choose your local friendly ordered pair 1, 1 because that's clearly to the right of it, or you can view it as being above it there. So let's plug it in. Plug in the 1 greater than negative 3 times 1. Is 1 greater than negative 3? Yes, it is. So because of that, we're going to shade on the side. Remember, that is a true statement. So we're going to shade on the side with the dots. And there we go. That's all you need to do for shading. All right, that's it. That's it. Kind of fill in the graph that's there. But yeah, that's it. Watch for dotted or solid, and then you have to choose a point and test it out. Let's do one last one. Let's go down to problem number 4. So we're going to need it to be in slope-intercept form. So let's subtract that 2x over. So I've got y less than or equal to negative 2x plus 3. Okay, let's graph. Go up 3, 1, 2, 3. I got a slope of negative 2 1s. Down 2 to the right 1, down 2 to the right 1. It is an or equal to symbol, so this is going to be a solid line. All right. And then we're going to test the points. Listen, I'm going to test out 0, 0. All right. Multiplying by 0, adding, subtracting by 0 is so friendly. So 2 times 0, 0 plus 0 less than or equal to 3. Hey, is 0 less than or equal to 3? Yeah, it is. So because it is true, we're going to shade on the side that has the point, which is your 0, 0. All right. That's it, people. Graphing like normal. We just need to now solid dotted line, and then we have to test a point out. All right. We'll see you later.